In this video, I'm going to talk about the division algorithm for polynomials. Before we look at the polynomial case, firstly, let's consider the integer case. After performing the long division for 28 divided by 9, we can obtain an equality relation like this. That is, the dividend is equal to the divisor times the quotient plus the remainder. Therefore, we can conclude that 28 is equal to 9 times 3 plus 1. The procedures of expressing the dividend in the form of divisor times quotient plus remainder is called the division algorithm. In this example, this is the division algorithm for integers. Now let's take a look at the polynomial case. In the division for polynomials, we can obtain the same relation from the division algorithm. Therefore, we can conclude that 4x cubed plus 5x squared minus 3x minus 4 is equal to x squared plus 2x minus 2 times 4x minus 3 plus 11x minus 10. This is not only an equation, but also an identity. That means both sides are identical and the left-hand side is equal to the right-hand side for all values of x. In the division algorithm for integers, the remainder needs to be smaller than the divisor, like in this case. On the other hand, in the division algorithm for polynomials, we have a similar requirement for the remainder. We need the degree of the remainder to be smaller than the degree of the divisor, like in this case. Now let's take a look at a few examples and see how we can apply this equality relation from the division algorithm to solve problems involving the division of polynomials. In this example, the dividend, the quotient, and the remainder are given. So from the relation dividend equals divisor times quotient plus remainder, we can solve for the divisor like this. To simplify this algebraic fraction, we can perform the long division like this. Or we can simply factorize the numerator and then perform cancellation like this. Therefore, we can get that the divisor is x minus 3. Afterwards, let's take a look at this example. In this example, the divisor, the quotient, and the remainder are given. So we can find the dividend by this relation from the division algorithm. Because these two expressions are identical, by comparing like terms, we can get that a is equal to minus 9 and b is equal to 4. Finally, let's take a look at this example. In this example, the divisor and the quotient are given. And now we need to find the remainder in this case. This time we cannot directly obtain the remainder from the division algorithm, because the dividend is not fully known. For the dividend, we only know that it is a cubic polynomial with f0 equals 5 and f2 equals 7. In this case, we can consider the requirement of the remainder that we have learned. That is, the degree of the remainder should be smaller than the degree of the divisor. Now the degree of the divisor is 2, so the degree of the remainder should be at most 1. Therefore, we can let the remainder be ax plus b, so that its degree is at most 1. And then from the division algorithm, we can conclude that fx is equal to this expression. Afterwards, by considering f0 is equal to 5, we can get that b is equal to minus 3. And by considering f2 is equal to 7, we can get that 2a plus b is equal to 7, and so a is equal to 5. After finding the values of a and b, now we can conclude that the remainder is 5x minus 3. This is how we can solve problems involving the division of polynomials by considering the division algorithm.